Okie doke. Very good evening, everybody. This is Paul, NO0T for the Front Range 6-meter group. And tonight we're blessed to have Mooneer Salem K6AQ. He's going to talk today about machine learning and the FreeDV system and show us how it works and what's new for amateur radio. So with that, Mooneer, if you'd like to start us off and go for it.
All right. Hi, I'm Mooneer Salem K6AQ, as previously mentioned. And basically, I'm just going to talk to you guys a little bit about FreeDV tonight and what we've been working on over the last year. So a little bit about myself. Been licensed since the early 2000s, original call sign being KG6AOV. I did the whole thing where you get in the hobby really strong initially, and then you get out of the hobby for quite a while. So I started back into it in like I'd say mid 2010s. And I decided to go upgrade to like general and an extra so I could get on HF. And then the rest is history pretty much. My day job, which I just came back from, is a software developer at a medical device company, mostly C and C++. I am wearing their swag right now. Just to make sure, probably obvious, but my views don't represent the company or anything like that. And then in my spare time, I do open source development. Well, my little spare time left, you might have saw my daughter in the video earlier. Spending most of my time doing that when I'm not at work. But in my little bit of spare time that I have left, I mostly do FreeDV development. So just a little bit of introduction on what digital voice actually is. Before we go further, can you raise your hand with Zoom if you guys have ever used like DMR or DStar or anything like that? Okay, so a few. So for those who haven't played around with say VHF and UHF digital voice, think of it kind of like live streaming but on the radio. So and I'm talking from a technical perspective. So basically how that works is there's some sort of microcontroller or PC that takes your analog voice, turns it into zeros and ones. And then there's software on that microcontroller or PC that typically turns it into a signal that radios can transmit. So it kind of goes from analog domain to digital domain and then back to analog again because RF tends to work as analog. And then it goes in the reverse the other way. So we convert the signal, comes in from the radio back into ones and zeros, which software turns back into a voice that goes out over your speaker. So why would someone do that? Basically convert from analog to digital and then back again effectively. Well, by virtue of digitizing that, we add some noise immunity. So when your signal is basically a 0 or a 1, there's a lot of leeway in what you can consider a 0 and what you can consider a 1. Versus like analog, where it's a lot harder to get back what you put into it. So, and of course, that's not 100% reliable. So a lot of digital voice modes also add what's known as forward error correction. And there's various trade-offs you can make with that. And depending on those trade-offs, you can actually fix a lot of issues with the received signal and actually get back something that's usable. But a bigger reason that people use digital voice is that it typically takes less bandwidth than a similar sort of analog signal. So for reference, sideband is about 3 kilohertz wide and FM is about 12 kilohertz plus. Depending on the digital voice mode, you can actually cut that in half or even more. And with a narrower signal, you typically have more power density, and that on its own reduces the minimum signal to noise ratio. That's why, for example, CW tends to get out when nothing does. Of course, it's not all sunshine and rainbows. Basically, one big disadvantage of digital voice is that either your signal is either there or it isn't effectively. So you either have full quieting or you're just not hearing anything at all. And that contrasts to a lot of the analog modes we're all used to. And an example of this, what's known as digital cliff effect, was back when we went from analog TV to digital TV. There were actually a lot of people in this country who didn't have Q5 reception of their local TV stations. Maybe there was snow in the picture or the audio wasn't completely crisp, but they could still understand what was going on. And of course, when those transmitters turned off and we were all 100% on digital TV, a lot of those people just couldn't get like TV anymore effectively. And as you can imagine, that really didn't go over well. Fortunately, it's a lot better now that people are just streaming stuff instead of watching over the air. But that was a big thing back in the day. And digital voice also traditionally didn't really sound as good as the best FM or sideband signal. A lot of the digital voice modes that currently exist tended to add a robotic quality to the audio, which didn't necessarily make it unintelligible, but for some people it made it quite annoying to listen to, so maybe they didn't do digital voice as often as they'd like. And we can definitely do a lot better than that. There's also some additional challenges for digital voice on HF. So HF tends to have a lot less spectrum available for our use than VHF and UHF. So contrast 2 meters where we have 4 megahertz available, or 70 centimeters where we have 30 megahertz of spectrum available. On HF, we might only have a few 100 kilohertz. And even then, we can't just emit a signal that takes up all couple hundred kilohertz of the bandwidth, at least without annoying everyone else who's using HF at the time. So in order to be able to fit our transmission on what's available, we have to cut some stuff out. And typically we cut out anything that's very low frequency, about 500 hertz or lower, or frequencies that aren't a bit possible on sideband typically. So anything above 3 kilohertz or so. We can't just cut them out and leave them cut out though, because that kind of makes your voice sound really weird on the other end. So there's various ways to reconstruct it on the other end. A general case is actually pretty difficult to do that, but if we know what we're transmitting, say speech, for example, we can actually take some shortcuts and simplify the reconstruction process. And there is something called sinusoidal speech coding, for example, which what we're basically do with that is just send fundamental frequencies and what's known as voicing data over the air, and we use that on the other end to turn back into a usable voice signal effectively. And that's used in the Codec 2 library that FreeDV traditionally used in the past, as well as the M17 project, if you guys are familiar with that. So that brings us to the main topic of the presentation. What does FreeDV provide exactly? Well, the big thing that it provides is digital voice that's optimized for HF band conditions. So one thing is that it's narrow enough that you're not going to piss off everyone on the band. And it's also able to handle HF band conditions, for example, fading and so forth, unlike with, say, DMR, for example. FreeDV also lets you use digital voice with your existing radios, so you don't have to buy anything new effectively. In fact, if you're already set up to do, say, FT8, for example, you're likely perfectly able to use FreeDV today. So has anyone here heard of FreeDV before tonight? Cool. So maybe like a couple people. So FreeDV has actually been around for quite a while. Originally, there was a program called FDMDV that came out in the mid 2000s, and it used a commercial audio codec at the time, but it was in kind of this gray area where the company who created that codec didn't really give hams permission to use it, but they also didn't say hams couldn't use it. And so because of that, hams were kind of just experimenting with it, but then things happened, and eventually that commercial company in question decided that hams couldn't use that codec anymore. So that killed the project pretty much immediately. And in response to that, a guy called David Rowe, VK5DGR in Australia, created the Codec 2 library, which I mentioned earlier. And it's an open source digital voice library geared towards HF ham radio use. Well, ham radio use in general, rather, because M17 uses it. And over the years, multiple different modes were added to Codec 2. And they range from about 700 bits per second to 3,200 bits per second at the higher end. And M17 typically uses the higher end of that, while traditional FreeDV use, sorry, while traditional FreeDV used the lower end of that. And as mentioned before, the Codec 2 library is integrated into the FreeDV application. So, and that was awesome, and we actually got some use out of it, but unfortunately, it shared a lot of the same problems of other digital voice modes. So it still had kind of the similar sort of robotic type audio quality as, say, DMR, for example, and, like magnified because on HF we had a lot less bitrate to deal with that. And then on top of that, Codec 2 sounded good for some voices and didn't sound all that great for other voices. And hopefully this works to give you an idea of what traditional FreeDV sounded like.
It's quite obvious. It's very behind the 30-foot tower, 30-foot mast. You can crank up so I can maintain the data on the, I can lower it to the top.
So as you could hear, you could understand what he was saying, but maybe not something you would necessarily want to listen to for a long period of time. And then on top of that, because the Codec 2 library had multiple modes to choose from, all optimized for varying different forms of HF propagation, the fact that users had a choice in what mode they could use added a fair amount of confusion, exacerbated by the fact that people there wasn't really great documentation around it. It was just kind of a table with the various modes and what the bit rates were and so forth. So people kind of just had to play with it from user experience. And even then, a lot of people just coalesced around one or two of the modes and just left it at that. So they left some performance on the table depending on what HF was doing that day. And then on top of that, it wasn't great for everyone because there were some people where the signal noise ratio had to be a lot higher than what was documented in order to get reasonable quality out of it. So it's definitely not a great user experience there. So that brings us to the stuff we've been working on for the last year. But first, I got to introduce you guys to machine learning. Have you guys ever used, say, or heard of or used, say, like ChatGPT or anything like that? So people for sure. That's the big hot thing that was going on right now. And how that works is it uses something called machine learning. So it's kind of a way to generalize new stuff based on what it was trained with. And typically you got to train on a lot of data in order for this to be usable. For example, in audio use cases, you would typically have to train on tens or even hundreds of hours of audio. And that training process requires a lot of math, which wasn't really possible on consumer level hardware until very recently, within the last few years. For example, you might be able to go to Micro Center or another hardware store and buy a new model NVIDIA card, and you'd be able to do this locally. And even 5 years ago, you would need very expensive data center GPUs to even be able to have a chance at doing this. And even if you didn't buy like a fancy GPU, like you could just go to ChatGPT's website right now and just ask it questions, and it gives you something that at least it's confidently incorrect about. So there's that. And then there's also a little bit further down, there's some AI optimized microcontrollers that are coming out. So that might make it possible to do a lot of machine learning tasks on, say, small devices instead of needing a computer, for example. So that sounds all awesome and stuff. I'm sure most people's experience with machine learning is just typing questions into a chat and getting some sort of answer out of it. So you might be interested in wondering how one would use machine learning for digital voice. And there's a couple of use cases for it. One use case is being able to better model human speech. A lot of audio codecs basically were developed by humans. So, and that relied on our understanding of how speech should be encoded and decoded. And it's possible that that's not the most optimal way. So being able to pass a bunch of audio into a machine learning system and have it generate some sort of waveform that can go out over the air based on that is actually pretty promising for sure. And especially since it has a concept of context where we can use what we previously received as well as what we just received to generate what we think is going to be next. So we can use it to patch up holes that say like a classical DSP algorithm wouldn't necessarily be able to do. We can also use machine learning just to even be able to decode like a digital signal in the first place. So we can pass, say, a signal that we're transmitting through various propagation simulations while we're training, and then use that to be able to decode when it's time to receive an actual live over-the-air signal. And we can iterate these models based on real-world experience and make them even better. And in fact, there's a few companies that have already been working on machine learning type codecs, mostly from Google and Meta / Facebook. And if you guys are interested, the links are up there. They're basically Encodec from Meta, also MLO from Meta, as well as Google's Lyra. And these all actually sound really not awesome if you like research them and listen to audio samples. But unfortunately, they still need a lot of bandwidth, so they're not necessarily appropriate for use on HF. And now we can get to what we've been working on for the last year. And it's a new FreeDV mode called Radio Autoencoder. And what we're basically doing with it is we're using very typical voice features like pitch and so forth to generate what's effectively analog PSK signal to send out over the air. And then on the receive end, we're basically converting that over-the-air signal back over to features that we can feed to a voice codec. And currently we're using what's known as the Fargan voice codec from the Opus project. But theoretically, we could do this with any voice codec that takes these voice features. So here's an example of what RADE sounds like versus sideband. So what you're going to hear first is the sideband signal, which is basically deep in the noise and fairly difficult to understand. And then you'll hear the RADE signal in those same band conditions. So first is the sideband. All right, and then next up is the RADE signal.
CQ, CQ, CQ. This is VK5 Delta Golf Romeo, Victor Kilo 5 Delta Golf Romeo. Calling CQ for UV 2020.
So as you guys were probably able to hear, the RADE signal was full quieting, no background noise. And it still didn't fully sound like David, but it sounded a lot closer to him than we've ever been able to get to with any sort of digital voice mode. And for those of you curious on how we got these recordings, we were basically doing some semi-automated testing over the air back last year, where we transmit a sideband signal followed by a RADE signal, and then basically recorded in an automated fashion from a web-based SDR. And then we can review the recordings later on to see how they sounded. And then, of course, that's not that was done a year ago, so we've done a lot more tweaks and updates since then. And hopefully when later on when I show you the application, we try to do a live demo. I don't know how well that'll work. You'll be able to hear the improvements since then. So I'm sure you guys are really, really excited to try FreeDV now. Typically people download the FreeDV application available at freedv.org. And there's pre-built program versions for Windows as well as Mac. But if you're on Linux, you can download the source code and build it yourself. There's also a script from Barry in the UK. I think it's G4MKT is his call sign. That will basically automatically build it for Linux if you'd like. FreeDV requires 2 sound cards to transmit, but that's not as bad as it sounds, because one of those sound cards is likely going to be the same interface you're using to communicate with your radio for FT8, for example. And the other one can just be a USB or Bluetooth headset, or even just the speakers and mics built into your computer. So I'll go ahead and open up a browser, and I can show you where you can download the. And of course, I typed the URL wrong, but it's freedv.org. So basically, you would just go ahead and click on the download link, and then you get direct links to the Windows and Mac OS versions, as well as a link to Barry's script that I mentioned earlier. And if you want to find out a lot more information about the releases we've been doing, there's also the direct link to GitHub, and you can view that as well. And the way that the installers for Windows and Mac work is Windows, you just double click on the exe and just run it like any other, install it just like any other program effectively. And on Mac OS, you double click on it, it opens a drive, and you can drag that to your applications folder. Kind of similar to most Mac applications effectively. So once you finally install it and you start FreeDV, you'll get what's known as Easy Setup page. It's effectively this window right here. And it's kind of a streamlined setup process for the most common use case where you have a radio plugged in via USB, for example, as well as like just a normal speaker and mic. So in this example, I set up my radio device for BB cable because I'm using a Flex radio here. And then I have the decoded audio playing back through Zoom audio device because we are doing the presentation, but normally you would just choose like another normal device here. For example, the speakers built into my Mac Mini or my Bluetooth headset, which is this OnePlus Bluetooth wireless right there. And then you can also choose your microphone, same deal. The OnePlus Bluetooth that I'm speaking to you with right now. And of course, if you don't happen to be running the most common use case, like if you're running an SDR that has multiple sound devices, for example, then you can always go to click on the advanced button and go through the advanced audio config. And in the advanced audio config, there's a receive and transmit tab. And what you would do is you would basically just go follow the path that the audio takes. So for example, the top here in the receive tab is the radio device for the receive side. And the bottom part of the receive tab is what you're going to be hearing the signal through. And then on transmit is reverse. So on top is what you're going to be speaking into. And on the bottom is what you're going to be transmitting out through over the radio. So once you have that all configured, you can go ahead and push OK. And then next you'll need to set up your cat control. And we support using hamlib, whatever radios hamlib supports, as well as serial PTT if you'd prefer to use that. And it works pretty similarly to how it would work in WSJTX, for example. So in this example, I have hamlib configured for my smart SDR. So I'm using a TCP for cat. So I'm basically connecting to port 5001 on my local computer. But you can choose just whatever serial port, say, for example, on Windows, this would have like COM1, COM2, etc. And then you could also override the rate, or you can also override the PTT method as well. So like if you want to do cat control for frequency and mode, but say trigger PTT via serial, you can do that from here. And serial PTT is similar sort of configuration. You can go and choose your COM port, as well as whether you're using DTR or RTS and what polarity they are. And then once you have the radio control and the sound device configured, then what you can do is you can push on the test button to see if everything's working okay. And if it is working okay, you see that the radio went into transmit and is transmitting a carrier. And that's good because that means we're actually, we have all of our audio devices configured properly. So I'll go ahead and stop the test so that I'm not polluting the airwaves with that. And then there's also an advanced button for this as well. You can go to advanced, and it has a same sort of configuration as with the easy setup. But there's also an OmniRig. If you're on Windows, there's an OmniRig thing that'll show up here. And then if you're using a foot switch as well, we support that. You can just click on Enable PTT Input and choose the COM port for your foot switch accordingly. And then there's also a separate test PTT, which just tests the push to talk without actually transmitting anything. And then finally, I highly recommend you enable reporting and enter your call sign in grid square. And that's that, and I'll explain more later, but that effectively helps people find you on the air and for you to find other people. So I'll go ahead and push cancel here because I'm already configured, but once normally you would just push OK to fully configure. And then the next thing you'll want to do is you'll want to go into the main window right here and go ahead and push start. Make sure you choose RAID v1 here as well. Uh-oh, hang on. We're going to restart that. Okay, so basically make sure your RAID v1 is selected because that's the mode we're talking about. There's these other existing modes here as well, but those are the older modes. And if you, as you can see up here, which we'll talk about more, most people are using RAID v1. So if you use these other ones, you probably won't get anything back. But anyway, so now that we're here, right, we're actively receiving, well, we're not, there's no one transmitting right now, but we are actively receiving a signal, like from the noise from over the air. So there's a couple things you can do on this main window. One thing is you can go in analog here. So like if you see that there's a sideband QSO going on, you can click on that and hear what they're saying. There's also a voice cure functionality, so you can pass it a WAV file that you pre-record, and it will basically just transmit that for a predefined number of times that you can configure. There's also the push to talk, which is what you would do to switch between transmit and receive. So one thing that's really, really important is you want to get your audio levels right. So in order to do that, you can go ahead and push to talk to start transmitting. And you'll want to adjust this TX attenuation up and down. Basically, you don't want, it works just like most other digital modes. You don't want to show any ALC at all. So if you're showing ALC, you're you're transmitting too loud and you need to back off. And if you don't do that, you'll end up with a signal that other people might not be able to understand. K6AQ. So on the flex, basically 0 is the correct one for me, but it really depends on the radio and what that looks like. So we'll go ahead and leave that here, and maybe someone will transmit and we'll hear them back from them. But let's see. Skip all these slides since we already discussed that. So occasionally there's questions on whether FreeDV itself is legal. I'm not a lawyer. As you guys heard at the beginning of the presentation, I don't work at anything approaching a law office. So I'm definitely not the expert here. So if you have any concerns about that, I would talk to someone who knows a lot more than I do about the law. I can't tell you what the ARRL has mentioned in the past. And they wrote an article called Practical HF Digital Voice back in 2000 in QEX. And they had a little sidebar. And in that sidebar, they basically had something that effectively said they consider digital voice as being J2E. And I don't know how many of you have really worked with emissions designators all that much. They're not really obvious at all, unfortunately. But what the J2E stands for is the J stands for sideband, effectively. The 2 stands for a single channel with that has digital information going out over it, and E means it's mostly voice that's going out. And if we accept ARRL's reasoning, then it's considered a phone emission. And because it's a phone emission, we can actually use it anywhere where we can, most anywhere where we can use, say, sideband or AM on HF. So basically the upper portions of each of the HF bands minus 30 meters typically. Also 60 meters for FreeDV because 60 meters is regulated a lot more strictly than normal HF, since we do share it with government stations, for example. On 60 meters, 97307 effectively limits phone to analog upper sideband. So currently, FreeDV is not legal on 60 meters for Americans, but there is something going through the FCC that might harmonize the 60-meter allocation that we have with other countries. And if that were to happen, FreeDV might become legal for us on 60 meters. So we'll have to see where that goes. There's also the question of whether FreeDV is actually J2E. One thing people brought up about that is that you theoretically don't need a single sideband radio to transmit this. Because you don't need a sideband radio, we're not actually J2E might not actually be the correct emissions designator. But there's also the argument that even if it isn't, we do have a lot of leeway as to what is considered phone. So personally, I'm not too worried about it. But again, if you have any concerns, definitely talk to someone who knows more than I do. But regardless of whether we can use the mode at all, a lot of the same stuff we got tested on when we got our licenses still applies. So we still need to ID every 10 minutes. Not transmit like kilowatt unless we absolutely have to, stuff like that. These are also all FCC rules that we should all hopefully still be doing, even when we're on sideband, or CW, or like any other digital mode. So definitely we want to be good stewards of the bands. And speaking of being good stewards of the bands, definitely should be listening if we're transmitting, because FreeDV usage has actually gone up a fair bit, but there are still a lot of people, for example, a lot of people here who haven't heard of FreeDV until tonight. So they may not know exactly what FreeDV sounds like, so they might accidentally step on people. So it's always a good idea to make sure there's not actually anyone transmitting rather, before actually transmitting on FreeDV or sideband for that matter. We also currently use the same upper sideband, lower sideband conventions as analog voice. And this is different than typical digital modes that you may be familiar with, since most digital modes typically only use upper sideband. So for those who may not have used HF much, we typically use upper sideband on 20 meters and above, and lower sideband on 40 meters and below. And we chose this for several reasons, the big reason being that it makes it easier to tell if someone's on frequency. If we're always on upper sideband, we might see someone transmitting in the waterfall, but we might not necessarily understand what they're saying. So if we're using the same sideband as everyone else, that makes it easier to make sure we're not stepping on people. We also have a few calling frequencies. Typically, most of the operation in the US is on 20 meters, 14.236, plus or minus a little bit depending on if there's anyone on frequency. But 40 meters on 7177 and 10 meters on 28330 are also fairly common. So I'll get out of the presentation again, and I can show you something really, really cool. It's called FreeDV Reporter, and it's our official spotting service for FreeDV. And that's why I was telling you guys that you should put your call sign in Grid Square. Because when you do that, and you push start, you'll show up in here. And the nice thing about FreeDV Reporter is that it's a live view of what you're actually doing on FreeDV. So for example, I can go ahead and transmit again. This is K6AQ transmitting on FreeDV for the front range 6 meter presentation that I'm currently giving tonight, K6AQ. So as you probably saw up here, the WA6NUT turned blue, and that's because he was actually receiving my signal. And you can see my call signs appearing right now on that row. So it also started appearing as blue as soon as I started transmitting. So it's a good idea of who is receiving you at basically live. And likewise, you probably also saw my call sign turn red up here, and it turns red whenever you're transmitting. So for example, this is K6AQ transmitting once again. And then of course, as soon as I stop transmitting, I'm no longer red. So that gives you a pretty good idea of like what kind of activity is going on FreeDV Live. And as you can see here, it's currently daytime in Japan. So there's a lot of Japanese stations that are starting to come on over there. It's actually really, really popular in Japan now. So definitely, depending on the time of day, you might be able to talk to some Japanese stations. But anyways, there's also so there's two ways you can view FreeDV Reporter. One way is what I'm showing here, which is the built-in program that's in FreeDV. And you can get to that by going to the tools menu and clicking on FreeDV Reporter. And that just brings up this window right here. But there's also the FreeDV Reporter website. And you can get to it by clicking on this website button, or you can go qso.freedv.org in your browser. And it has a similar sort of view as what the built-in program has. Like you see a list of call signs and you get the live view here as well. So for example, go find where my call sign is down here. FreeDV testing again, K6AQ. You can see I turned red here, just like I did with the built-in program. And I also, the people who received my signal also turned blue here. And on the web-based version, which isn't in the built-in one, there's a chat view here. And what you can do is you can basically talk to people on here and coordinate contacts live. So for example, you can just log in with your call sign here and just start chatting. And you can see who's on the chat view at any given moment. And then at this as well, you can see people's call signs are highlighted. So you can click on their call sign and you can click on, say, QRZ, ham, QTH, or ham call, QRZ, for example, and you can view people's pages that way and their information in a fairly straightforward and easy manner. The web-based version also has a list of calling frequencies that you're currently using, and you can also get to this from the program itself, this report frequency down here. You can choose one of the frequencies in the drop-down list. And if you have cat control configured, then it will change the frequency on your radio. So for example, if I choose 40 meters, 7177, and I go back to Smart SDR, you'll see that I'm on 7177 now. FreeDV also changed my mode to lower sideband to match our current conventions. And if I go back to 20 meters, you can see that, oh, well, I guess we found a bug together, so that's cool. I'll go ahead and put that back on upper sideband real quick. Normally that's supposed to auto switch to upper sideband. But anyway, so I'll make a note of that for after the meeting. But yeah, if you change the report frequency here, it will auto adjust here. Likewise, if I go ahead and type a frequency here, like 14305, for example, then you can see it updates to 14305. And I'll go ahead and put it back on 14336. And one final thing that's really, really cool is you can actually ask someone to switch to your frequency. So for example, if I click on K7AC right here, you'll see that the request QSY button shows up here. And I can go ahead and, well, I'll go ahead and push it. And you can see it send a QSY request to that user. And what that basically does is they'll get a message on the other end. And they can choose yes or no. And if they choose yes, their frequency will switch over to your frequency. So that's really, really cool to help you find people to talk to. So I think that's it for FreeDV Reporter. We also support PSK Reporter. So if you're familiar with FT8, PSK Reporter works pretty similarly with FreeDV. So for example, I have my call sign here, and the test transmissions I've been doing were heard by W86 and UT, as mentioned before. So you can see that he received me 4 minutes ago. And if you click on that, you get the information about that. You can also, a cool thing you can do here is you can also get a really good idea of how much FreeDV activity there has been over a period of time. And you can do that by clicking on this FreeDV mode right here and clicking on anyone. So you can view all the FreeDV activity in the last 24 hours. So if I zoom out, you can see, as I was mentioning before, there's a lot of activity in Japan. And there's a lot of activity in Argentina as well as in Europe. So it's definitely becoming more and more popular outside of the US for sure. And there's also some users in the US, and we're hoping to increase that every day. So let's I'll go back to the slides. Skip over PSK reporter since we already talked about that. There's also what's known as FreeDV Activity Day. This happened this past weekend, but it typically happens on the third weekend of every month, both Saturday and Sunday, starting 12 a.m. Pacific on Saturday to 11:59 p.m. Pacific on Sunday, with the corresponding Zulu times on the slide. It kind of works similarly to the JS8 call activity day, if you guys have ever used JS8 call before. So it's not really a contest, it's just like a set time that people get together on FreeDV. And during that weekend, there's always a lot of people on FreeDV playing around with it. So if you're having trouble finding people and any other time, definitely give the activity day a shot. So what are some next steps with what we're doing with FreeDV? One big thing we want to do is get integrated inside radios themselves rather. It's nice being able to download a program, but not everyone wants to download a program and set that up on their computer. They want to be able to open their fancy brand new radio, turn it on, push the FreeDV button, and get to work, right? So we want to get to a point where that's possible, and actually in radios that are currently sold out in the market. Because other than it being pretty cool, it also, as I mentioned, it makes it easier to configure stuff since all the levels and all of that have already been set up for you by the manufacturer. So you just push the FreeDV button, get on the air. And if you happen to know anyone who works for a radio manufacturer or any other kind of sort of connection like that, definitely reach out to me offline. So that's it for the main slides. Go ahead and open it up for questions if anyone has any.
I'd like to know more about the interface hardware and the radios. You said you don't have to have SSB radio, so what does it mean?
So on say WSJTX, for example, when you go and configure it, you're typically telling it what kind of radio you're using and like what COM port it's on and that sort of thing, right? It works similarly to that in FreeDV. So like if you say for the common case where you have a radio that has built-in USB, you basically plug a USB cable into your computer, and on Windows and other operating systems, typically it'll create a sound card and it'll create like a COM port effectively. And that's what you would be passing to WSJTX or any other digital application. So on FreeDV, that's what would effectively be the radio interface. And then the analog interface is what I'm calling it, which is your normal speakers and microphone. That would be your USB headset or a Bluetooth headset, or like if you're using a laptop, for example, maybe it's the speakers and microphone built into your laptop. Hopefully that answers your question.
Not the radio. What mode is the radio set?
I'm sorry. I misunderstood. Yeah. So FreeDV actually will be able to actually set the radio to the correct mode typically. But if you prefer to, there's a setting in FreeDV and you can have it not touch that and you can control the mode yourself. Typically, if your radio has that available, you'll want to do digital upper sideband or digital lower sideband. And if that's not available in your radio, just regular upper sideband and regular lower sideband work as well. We typically just recommend the digital versions of those because those usually don't do any additional processing on the signal that's going in and out of the radio.
Yep, that's clear now. Thank you.
Yeah, could you tell me how your project is related to M17, if it is?
So M17 and FreeDV use the same codec 2 library for the digital audio codecs, or it traditionally did anyway. M17 is still using codec 2, and we're actually going more towards this machine learning thing on our own. But in the past, we've traditionally used the same codec library as M17.
Okay, thank you.
I just, Mooneer, what radio are you using to be on, say 20 meters?
I'm using a Flex 6300 right now.
Okay. Have you ever tried it with like with an ICOM 705 or 7300?
I have a 705 and I actually have tried it and it works pretty well on that.
So where do you get the second sound card? Is because it sets up a sound card automatically, like you said, when you connect it to the computer. So do you need to put another sound card in your computer or just use the one that was originally there?
You would just use the one that's originally there. Or like if you connect like you can pair like a Bluetooth headset, for example, to your computer or laptop, for example, and it'll show up as a sound card in FreeDV, and you can choose that for your analog interface.
I see. Okay, great. Thanks. Oh, one more thing for 6 meters. So I know you were talking about, obviously you got to use this thing for, when like example, like 10 meters. We get similar propagation with eSkip and with trans-equatorial propagations, and we get lots of fading in and out, especially on, like I said, when you got eSkip going on. And I was just curious as to why you haven't tried 6 meters yet, or
We've been doing a lot of our development on HF, and we've kind of been targeting HF. In the past, people have used FreeDV, the older FreeDV modes rather, on say like satellites, for example, or like bands higher than 10 meters. And at least with satellites, that's actually worked pretty well. So it's definitely something you guys are definitely free to give it a shot, and see how that goes. Because we haven't really done much, like any testing on anything higher than 10 meters with the new RAID mode.
is there a method to your madness of picking what frequencies, or like
Or like calling frequencies, or
yeah, like you had 177 on 40 meters.
so a lot of the existing frequencies were there when I started working on the project. So I can't really comment on how those were chosen.
Okay.
But there were some changes to the calling frequencies, especially on the lower, like 80 and 160 meters. Because like because different countries have different allocations for those bands. So we were basically aiming to be as inclusive as many countries as possible. And of course that's not guaranteed. So if you look at the calling frequency page, you'll see a lot of different like calling frequencies for like 80 meters, for example, because in different IRU regions, 80 meters go like is different. So whatever we have for America, for example, isn't necessarily usable in Japan, as an example. Just as an example.
We're
I need to kill this because so I think someone's trying to transmit while we're doing the talk. So
okay.
Hopefully that made sense.
Yeah, no, it's been great. Thank you so very much. Any other questions, guys? I mean, this is like science fiction. It kind of reminds me of when we started getting into Q65, and that is very similar in how you did that. So it's a good way of trying something new on 6 meters, and we'll just figure out what frequencies are good ones. Like 110 right now is for DX. Sorry, 125 is for like DX, and we could pick another frequency up a little higher, I'm sure. So it's pretty good. It's breaking the mold.
Yeah, for sure.
Well, what about VHF and UHF? I think you have much wider bandwidth on those frequencies. That like the FM that you can do on 2 meters or 70 centimeters, even 23. Has anybody tried VHF, UHF?
So as I mentioned just earlier, people have Maybe not necessarily RAID, but people have used the older FreeDV modes on, say, satellites. I don't know if anyone's necessarily just done weak signal work on say 2 meters with it, but it is something you can definitely try and see how that goes.
Is it hard to get the machine learning that's already there, or is that already built into the software that you've got now?
It's built into the version 2.0 that we have out now.
So how do you add more learning later? Is there like an update opportunity?
Basically, if you join the mailing list or Discord, there's typically and mailing lists are linked on the website. There's a like release announcements get posted there, and you can download new releases that way. And if there's a change to the model or anything like that, the new versions will definitely have it. We are working on some stuff that but I don't have an ETA on that. So right now, the 2.0.0 is actually your best bet if you want to play with FreeDV today.
Great, thank you. Any other questions?
Yes, I'm curious as to what the transmitted signal, it doesn't look analog, it doesn't look traditionally digital, but can you kind of characterize the over-the-air waveform?
So over the air, it's about you can kind of see it in this frozen view of the waterfall. It's about 1.5 kilohertz wide. So I can see if I can get this working. Let's see. Oh. So let's see if I can get this working. So what I'll go ahead and do is I'll go ahead and click a pre-recorded signal right here. So that's kind of what it sounds like on the air. I don't know if that answered the question or not, but the signal is as I mentioned, it's effectively analog PSK.
Okay, no, that's excellent. Just it doesn't look like a traditional PSK with an eye pattern or anything like that.
Mm-hmm. And also, like, you can kind of see what that person's coming in pretty weak, but you can kind of see what it looks like on the radio waterfall instead of just a FreeDV one.
Excellent. Thank you very much.
That's really, really cool. I just can't it's so cool. I never dreamed of anything like this. Obviously, you guys have been working really hard in the background there just to make it up to 2.0. I can't imagine what 3.0 is going to look like.
Oh, definitely huge learning curve for average ham radio. I consider myself as technically inclined, but it still have to be time for me to chew it really right.
I'm going to need a lot of hand holding just to get through this. Okay, well, if there's no more questions, I'm going to let him go and take care of his baby and everything else in his house there. So, but thank you very, very much for spending the time with us, Mooneer. And you're always welcome to come back anytime you've got something new or you want to talk about something. We have these Zoom calls every so often, and we post it onto our YouTube page, the Front Range 6 Meter Group YouTube page. So I'm sure a lot of people will be going over and over again your explanation, and thank God we got it recorded so we can stop and play it back and forth a few times. Thank you, Mooneer.
No worries. And if you have any questions later, you can always just email me directly. I'm mooneer@gmail.com, or you can just go to our Discord. If you're watching it on I don't know if you can scan the QR code from your phone, but The Discord link is on freedv.org. So you can just follow that and load our Discord and ask me there. My username on Discord is The Mind Is Watching, but my call sign is going to be next to that, so you'll be able to see what who I am on there. But anyways, thank you guys for having me, and definitely a great presentation. And I'll definitely look you guys up if we have anything new.
Thank you so very much for being there.
Thank you,
No worries.
Mooneer.
Have a good night, everyone.
Thank you.
Thank you. Thank you.
Thanks, everybody. Good night.
Good night.
Good night, Paul.
Take care.